Hi everyone, my name is Dennis Gomez and I will present to you lab number 4, your first hack part 2. In this lab, I was able to gain root access to the Kioptrix level 1 machine. I performed lab 3 to identify the vulnerabilities of the Kioptrix level 1 machine after performing the nmap 1.192.168.56.0/24 command in my Kali Linux VM. I was able to identify the Kioptrix level 1 IP address as 192.168.56.103. I confirmed it by typing this address in the browser, and the test page from the Kioptrix machine appeared after searching the web page. The first step on the process of gaining access to the Kioptrix level 1 machine was to start Metasploit by typing msf console in the Kali root command prompt. This started the Metasploit version 6 1.4 DEV. The second step is to identify the Samba version that the Kioptrix level 1 machine was running by running the following command: use auxiliary /scanner /smb/smb_version. Then I type set rhost 192.168.56.103. This pointed the Kioptrix level 1 machine. Once I targeted the Kioptrix level 1 machine, I ran the following command: run. By running this command, I was able to identify that the Kioptrix machine is running Samba 2.218 version. The third step is to search the Samba 2.2.18 raw remote code execution for Linux BSD in the exploit database. You can access it by clicking the following link below. Step 5 is to copy the Samba 2.218 raw remote code execution from the exploit database. Step 5 is to paste the code you copied from the exploit database website on a program opened by the Kali command prompt. To open the program in the command prompt, you will type the following command: vi10.c. 10.c is the exploit number given to this Samba exploit by the exploit database website. You will paste the code by typing I and then Ctrl+Shift+letter V to paste. After you have pasted the code, you will press escape and type :WQ to save it. Step number 6 is to run the code in the compiler by typing gcc 10.c switch o 10. Switch o is for the output file. If an error is returned, you will have to provide a different name to the file that contains the code you copied from the exploit database website. In step number 7, you will run the command with the code by typing :/10 switch b 192.168.56.103. The :/10 is the command that runs the code copied from the exploit database website. Switch B is the platform in the program, and in this case it would be brute force. 0 is the system in which we will run the code, which is Linux. The last segment of the command is the Kioptrix level 1 IP address, and that is 192.168.56.103. Hit enter, and now you have successfully performed the exploit, and you should have root access to the Kioptrix level 1 machine remotely. In step A, you will add the user to the Kioptrix machine by typing /user/sbin/user_add and then the user. After you hit enter, it will prompt you to add a password. Once you add the password, you will update the authentication information. In addition, you will escalate privileges to that user by typing the following command: echo user all equals (all) !/etc/sudoers. If the command is executed successfully, you will see the user you added with all the permissions. Now we will move on to the attack families. The first attack family is the buffer overflow. Buffer overflow is when an attacker exploits a victim's memory vulnerability by overriding it by sending additional volumes of data that could cause the program to corrupt files or expose sensitive information. If an attacker were to know the system's memory layout, they could maliciously send extra bytes of code to override a pointer that will gain access to the system. There's two types of buffer overflow attacks: stack-based and heap-based. The stack-based is the most common and it consists in carrying the attack by leveraging the stack memory of the system. The heap-based attack is more complex to carry out and it consists of causing a denial of service to a system by overflowing the memory space allocated. To prevent this attack, it is important to implement address space randomization, data execution prevention, and structure exception handler. Override protection. The second attack is privilege escalation. Privilege escalation is when the attacker gains unauthorized access to a system and can obtain root access. That means the highest rights and privileges. In privilege escalation attack, a hacker will try to find a vulnerability that will provide him with unauthorized access to a system. After obtaining the access, the hacker will attempt to obtain more additional access until eventually they possess administrator rights to access more sensitive information. If a system is not set up properly, that means having weak security controls or the absence of the least privilege principle, the hacker will successfully be able to perform this task. Privilege escalation can allow hackers to gain access to other applications and connect a system, deploy more malicious code as the root, modify security settings or privileges, gain access of an entire network. The privilege escalation attack vectors are credential exploitation, vulnerabilities and exploits, misconfigurations, malware, and social engineering. A rootkit. The fourth attack is a rootkit. A rootkit is a hidden computer program that allows a hacker to control a computer with privileged access by going unnoticed by the victim. When running the rootkit, the hacker can spy on the victim, execute files remotely, and change system configurations on the victim's machine. Rootkits can be found in the form of trojans, worms, or viruses sent over phishing emails. The next attack that we have is a Trojan. A Trojan, also known as the Trojan Horse, is a type of malware that disguises itself as a legitimate file but contains harmful code that once clicked by the user will execute on the victim's computer and provide a hacker with access to it. The type of Trojan viruses are backdoors, exploits, rootkits, bankers, DDoS, and downloader Trojans. Backdoor will provide remote access to the hacker for executing or downloading files. Exploit will take advantage of a victim's system vulnerabilities. Rootkits will run silently on the victim's machine. Bankers will try to steal financial information. Distributed denial of service will flood a network with requests until it brings it down. The downloader will run additional malware. The next attack is the backdoor. A backdoor is when an unauthorized or unauthorized user accesses a network, computer, or application in a discrete way and obtains admin access. When authorized users run backdoors, they can help customers with troubleshooting and resolving their software issues remotely. When unauthorized users run backdoors, they can steal sensitive data, execute additional malware, and even cause distributed denial of service. The next attack is the computer virus. The computer virus is a malicious code or program that replicates from host to host and causes damaging effects from corrupting data to stealing passwords. Furthermore, viruses can log spy on a victim, spam, email contacts, delete files, and hijack devices, among many other atrocious things. Viruses attach to programs, files, or documents, and they infect the computers once the code has been executed by user interaction of clicking emails and text messages, attachments, downloads, or links. The different types of computer viruses are boot sector viruses, web scripting viruses, browser hijackers, resident viruses, direct action viruses, polymorphic viruses, multi-party viruses, and macroviruses. The next attack is return-oriented programming. Return-oriented programming is a security exploit technique that executes code remotely on the victim's computer by obtaining control of the call stack, which controls and manipulates the trusted installed software. The call stack controls the subroutine execution of a computer program. Return-oriented programming is similar to the stack buffer overflow attack, which hackers can cause a program to crash by overriding the program's call stack with longer bytes of data than it can process. Additionally, it can cause the memory pointer to call other subroutines that the attacker desires. The next and the final attack that we will discuss is called common social engineering attacks. These are attacks in which a social engineering, also known as a con artist, gather information about the target organization by intimidating users into providing them with sensitive information by pretending to be trusted users. This collected sensitive information can serve them to gain unauthorized access to critical company resources later on. The social engineering attacks can be baits, scareware, pretexting, phishing, psychological manipulation, trust factors, and spear phishing. Thank you for listening and have a good one.